Alright, we're going to move right along the Chapter 9 review. We're going to move on to numbers 13B, 13D, and 14D. Okay, we have our flowchart right here. Make sure that you always have that handy so you can use it. We're just going to go right into it. How many atoms are there in 3.87 grams of krypton? Okay, so how many atoms? That means that we're going to finish at atoms, but we are starting in 3.87 grams of krypton. So that means that we're starting in mass, which means that we're going to have to go from mass all the way to atoms. Now, if we're going from mass all the way to atoms, our bridge is going to have two columns, right? Because we're going to need to pass by moles in the middle, okay? So let's go ahead and let's form that bridge, and I'll show you guys how to set it up, okay? So I'm going to move this up here so we have enough space to work with. Okay, so let's set up that bridge. We know that we need to set up a bridge with two columns in it, okay? And we know that in the middle we're going to have to pass by moles, okay? So let me go ahead and put this on here so you guys can continue to see it. Alright, so we are starting with grams. So we have 3.87 grams of krypton. Let's go ahead and write that down. So we're going from mass all the way to atoms, which means our first conversion factor is going to be from mass to moles, which is 1 mole over the molar mass. So let's start with the grams that we have. 3.87 grams of krypton over 1, right? That's all that we put. Now we're going to go ahead and we're going to put this 1 mole of krypton is going to be how much of the molar mass of krypton, okay, over how much of the molar mass of krypton. How do we know the molar mass of krypton? We go ahead and we just look at our periodic table. On our periodic table here we have krypton. You can go ahead and see it in your own periodic table. This periodic table is a little small, you may not be able to read that, but it says 83.798. 83.798. So I'm going to go ahead and write that down. 83.798 grams of krypton. Now all that means is that 1 mole of krypton is going to have a mass of 83.798 grams. Okay, so next conversion factor. This is the moles part that we did in the middle here. Now we have to do one more conversion factor, right? We're going this way. So now we have to do Avogadro's number over 1 mole. Remember, we want to finish in atoms, okay? To finish in atoms, we're going to have to use Avogadro's number. So this Na, remember, means Avogadro's number. So we're going to write that 6.022 times 10 to the 23rd atoms of krypton over 1 mole of krypton. And all that means is that in 1 mole of krypton, you have that many atoms of krypton. Okay, I'm going to move this out of the way so we can continue to work. In fact, let me move it down here, and then you guys can still see it. Okay, so let's finish this up now. And all we have to do now is plug this into our calculator. But first, let's cancel everything out to make sure that we finish with what we want. We want atoms. We started with grams. Grams is going to cancel out with grams. Moles is going to cancel out with moles. We're going to be left with atoms, which is exactly what we want. So let's go ahead and write down our answer by plugging it into the calculator. Okay, so we start with 3.87 divided by 83.798 times 6.022 second E23. Okay, we go ahead and we do that, and we get an answer of 2.781. And let's go ahead and write that down. 2.7811, and then let's just do one more significant digit there, 1. Okay, so I just went ahead and I rounded, and this is times 10 to the 22nd. Okay, 22nd atoms of krypton, but remember, we're not done yet because we still have to find out how many significant digits. We started with 3 significant digits. This has a ton of significant digits, but it doesn't matter because it is a conversion factor. Remember, we do not take into account conversion factors when we are working with the significant digits, okay? So let's go ahead and let's just make 3 significant digits here, which are just those 3 right there, okay, to the 8. Now, 5 or more, let it soar. 4 or less, let it rest. That 1 tells us to let it rest. So our final answer is going to be 2.78 times 10 to the 22nd atoms of krypton. And that is our final answer there. Okay, let's move on to the next one. Okay, so that's your final answer. Make sure that you can get that same answer. Okay, so the next question is how many formula units are in 8.58 grams of sodium iodate? We're familiar with sodium iodate. We did that in the previous problem. We're familiar with the term formula units. Remember that this is basically like saying atoms. Okay, so right here, units, atoms, molecules, they all basically mean the same thing. How many formula units are in 8.58 grams of sodium iodate? Let's say what we're starting with. We are starting in grams again, and we are going to formula units again. So we're doing the same exact path, okay? Mass to moles to atoms, which means that we have to set up a bridge with two columns, okay? Your bridge does not have to look nice, it just has to get the job done, okay? So we're starting with the mass. Let's go ahead and let's not waste any time. We have 8.58 grams of sodium iodate, okay? And remember, we put that over 1. We have to go through moles. This is the conversion factor that we're going to use. 1 mole of sodium iodate, okay, over the molar mass of sodium iodate. Now, this part's a little bit trickier because now we need to figure out the molar mass of sodium iodate. And we can't just go on the periodic table and find one thing that tells us sodium iodate because sodium iodate is a molecule. So we're going to have to figure out what added together, right? Sodium iodate. We're going to have to use the chemical formula to find out the molar mass of sodium iodate. So I'm going to do a little section right here where we can find the molar mass of sodium iodate, okay? So this is how I want you to do it. I want you to write out each element that is present. So you're going to write sodium, you're going to write iodine, and now since oxygen has 3, let's go ahead and just write O3 there. Now let's go on the periodic table and let's figure out what the molar mass of sodium is. Here it says that sodium is 22.990. 22.99 is fine. Iodine, if we look at iodine right here, it's a halogen. We have 126.904. I'm just going to put 0.90. And then O3, oxygen. Here it has 15.999, but on most periodic tables it's just 16.00. So I'm going to go ahead and write that down. 16.00. Now all you have to do is add this up. But if you see here, we can't just write 16.00 because that's for one oxygen, okay? So in fact, this right here would give us the wrong answer because that would just be sodium, iodine, and oxygen. But we actually have sodium, iodine, and 3 oxygens. So we have to rewrite this as O3, which is 16 times 3. Okay, so 16 times 3 is going to give us 48. Okay, so we're going to rewrite this as 48.00. Now we can add this up. And if we add that up, let's just use our calculator. 22.99 plus 126.90 plus 48.00. Now those zeros obviously at the end don't really matter that much when you're plugging them in, but just to be safe, we're going to plug everything in. And then we end up with 197.89 grams. Okay, so the molar mass of sodium iodate is going to be 197.89 grams, and that's what we're going to write down here. 197.89 grams of sodium iodate. All this means is that 1 mole of sodium iodate is going to have a mass of 197.89 grams. Okay, so we went ahead and we found the second part, which is going from, the first part, which is going from mass to moles. Now let's figure out going from moles to atoms, okay? So from moles to atoms, we're just going to go ahead and use Avogadro's number at the top, all right? So Avogadro's number over 1 mole, okay? Here, 1 mole of sodium iodate is going to have how many formula units? It's always going to be the same, always going to be Avogadro's number, which is 6.022 times 10 to the 23rd units of sodium iodate. Okay, now let's go ahead and let's finish this up. How do we do this? We plug it straight into the calculator. Alright, so to plug this into the calculator, you start with 8.58. You're going to divide it by 197.89, and then you're going to multiply times 6.022 E 23rd. Okay, and then you're going to get a big number. Why is it important that you know if you're going to get a big number or a small number? Well, we're going to atoms, right? Atoms, imagine how many atoms there are going to be in 8 grams, 8.5 grams. It's going to be a ton of atoms, okay? So it's important that you understand right off the bat that yes, your final answer is going to be something relatively big, okay? So this final answer that we have here is 2.61098, and then we'll just put 4 there, okay? And what is it? It's units of sodium iodate. I'm not going to write sodium iodate. Fine, sodium iodate. Okay, so that's what we have, but we have to look at the significant digits, of course, okay? So we start off with 3 significant digits. Now, it's not always going to be 3 significant digits, okay? But by coincidence, or not by coincidence, but by design, most of these problems are in 3 significant digits. We cross out what we don't end up with. We finish with units, which is what we wanted, right? Formula units is what we wanted at the end. 3 significant digits is going to be just that. 4 or less, we're going to go ahead and let that rest. So our final answer is going to be 2.61 units of sodium iodate. I'm sure you can hear my dog in the background. Sorry about that. Okay, so that's it. That's the final answer for 13D. Okay, now number 14, letter D. I'm going to go ahead and move this up. I want you guys to work on this one on your own. Okay, I am going to give you the answer though. Okay, so look, all it's asking, what is the mass in grams of 3.17 times 10 to the 18th formula units of sodium iodide? This is basically the same exact problem that we just did here, just flipped. Okay, if you look over here, how many formula units are in grams? Here, how many grams are in formula units? So you're just literally going to go through here, and you're going to start in the formula units or the atoms, and you're going to make your way through the top to mass. Alright, so that's all you're going to do, but I'm going to go ahead and give you the final answer for number 14D, and the final answer for this question right here is going to be 1.04 times 10 to the negative 3rd grams of sodium iodate. Okay, and it is possible to have an exponent to the negative because that just means that it's going to be 0.00, let's see, 1, 2, 3, yeah, 0.00104 grams of sodium iodate. And that kind of does make sense because here you have 3.17 times 10 to the 18th formula units. We know that 10 to the 18th is less than Avogadro's number, so it's going to be less than 1 mole. Since it's less than 1 mole, it's obviously going to be less than 1 gram, right? Much less than 1 gram because we know that the molar mass of sodium iodate is going to be 197.89. This is going to be something a lot smaller because there are a lot less units and less atoms in there. Okay, so that's the end of this part, and then we're going to go ahead and move on to other questions in the next video.